Okay, guys, this is June 2021 question paper that we are going to work on question number 8, and that is question 8.1. We are given in the diagram, which is the whole of this diagram that we are seeing here. I'm just going to try to minimize so that you see there. We are given this diagram that we have. MP is a diameter. All right, so there is MP, which is the diameter of this circle, centered at O. MP cuts the chord NR at T. So the chord NR is being cut by this diameter at a point T. When they intersect at T. The radius NO and the chord PR, MR, and MR, that is MN and MR, are drawn. So these are other chords, radius, and so forth. And we're given the angle R1, which is 69 degrees. That is our R1 from the diagram, 69 degrees, which is this part. But remembering that there is R1 and R2, which is the combination of these together, but there we're just considering R1. Okay, so with this information, our first question was to determine, not just to determine, but also giving reasons for that. All right. The size of, all right, let's consider the first one, 8.11, that is R2. All right, angle R2, that is 2 marks for that. Let's consider where R2 is. Remember, I talked about this, that there is R1 and R2 here. But what is it about this R1 and R2? What is it that we have? Okay, before we can see that we are given a diameter, and we understand that a diameter, what it does is it subtends an angle of 90 degrees at the circumference of the circle. A diameter creates an angle of 90 degrees at the circumference of the circle, or angles in a semicircle. If you consider this diameter, it creates an angle at R here. The whole of angle R there is 90 degrees. So if this whole angle that we are seeing at R here is a right angle or a 90 degrees, what does it mean? It means I can calculate R2, because R1 and R2 combined, they must give us a 90 degrees. So that is the condition there. So I'm simply saying the angle MRP, which is our angle R in this case, let's start by that. Our angle MRP is equal to 90 degrees. And what is the reason that you're talking about the angles in a semicircle, or angle subtended by a diameter, is 90 degrees? So you can just write this in short, angle in a semicircle, or just angle in a semicircle. All right. I'm gonna try by all means to bring out these theorems, like the way that they want you to present them in a shorter way. I'm just gonna bring out the PDF so that you see everything, so that it can help you also to minimize when you're writing. Remember, there are a lot of things, and you're supposed to do those things in 3 hours. There's a lot, so you can just write in short. All right, angles in a semicircle, or angle subtended by a diameter, is 90 degrees. So if this angle is 90 degrees, therefore I can calculate angle R2, because simply if I add angle R1 plus angle R2, which is this one, that is the one that we are referring as the 90 degrees that we're given, and R1 we have, which is 69 degrees. So 69 plus angle R2 must give us a 90 degrees. So I simply have to subtract this side. That's our angle R2 is equal to 90 minus 69 on this side. So you're going to subtract 69 degrees. 90 minus 69, this was going to give us 21 degrees at the end. So this is our angle R2. That's our angle R2. But remember that, okay, this is what we have. So let us just consider this. Remember that every time, whatever that you are supposed to do when answering these questions is all about the theorems. All right. So all this, I cannot just write this. I can just even write 90 minus 69 straight, if you know that There's no need. All right, let us consider the other part of our question. We are given to calculate angle O1 on 8.12, that is angle O1. Okay, 2 marks for that. Where is angle O1? Angle O1 is here. This is where we have our angle O1. I want you to consider that this angle is at the center. And what is it that you're supposed to think? The moment you are given an angle at the center, think of the theorems. What is it about the angle at the center? We do understand that the angle at the center is always twice the angle that is at the circumference of the circle. So if it is like that, that the angle at the center is twice, we are supposed to know the chord that is creating that angle at the center. That is the first thing. You are supposed to consider first the chord creating the angle at the center. It's called Mn. Let's consider that. Mn is creating an angle here, O1. Look, it's creating angle O1 there. We get hold of the same M and N. Let's get with it to the circumference this time. Where is it going to the circumference? It is going to R and back to N. It is going back to the point N. The same chord which created the angle here at O1 is the same chord creating the angle there at what? At R1. Only that this is at the circumference. This is at the center. That is the only difference, but both are created by the same chord Mn. So therefore, it follows that this angle O1 is simply going to be twice. So angle O1 is going to be 2 times angle R1, which is 2 times 69 degrees. So the concept there of multiplying, what is the reason? Angle at the center. So you can just write in short, angle at center is equal to 2 times angle at circumference is equal to 2 times angle at circumference. All right. What is the idea there? Once you are given the center, the theorems, all about the theorems. So the angle at the center, twice, 2 times, double the angle at the circumference. So take note, the angle at the circumference is R1, this one. This is the one that you're considering. So if you were to multiply this, 69 times 2, that was going to give us 138 degrees. All right, we are done on this part. That's our angle O1, which is 138 degrees. So with this, we are also asked to calculate angle M1. Angle M1. M1 is the angle that is found at the circumference of the circle. This one, that is where we have our M1. Okay, if I'm to consider this properly, I want you to go back here where M1 is. Hold this M1. Where is it going? I mean, hold from M to the circumference. Let's go to the circumference. Let's go to the circumference. Where are we going? To P. Let's go back to M1, okay? Take note. We want to know the chord creating M1, okay? So M1 is created from this line here, which ends up at what? Which ends up at P. We go back to M1, okay? Let's go back to M1. Where is it going? Where is it going? To the circumference. Let's go to the circle here. Where is it going? It is going to M to N. That is where it is leading us to. It is leading us to N. So it means this was created by the chord NP. You hold this chord NP. This is the chord creating this angle, or the arc NP, this one. So it's either you are referring to the chord or the arc. The chord or the arc. Okay, so now we can consider to say, where is also this chord creating the angle? Is it also at the circumference or at the center? Okay, holding the same chord, this same chord that we had, which created the angle at M1. Let's hold it now, NP. Where is it creating the angle? If we check, it is creating an angle there straight to the circumference. We want to the circumference, straight to the circumference. It creates the angle at what? At R. Okay, we hold P to the circumference. Where is it going? To R, like this. They meet at R. So what is it about this chord NP? it creates two angles at the circumference, R2 and angle M1 at the circumference, at the circumference. So what is the idea there? These two angles are equal, all right? So meaning to say 8.13, our angle M1 is equal to angle R2. That is angles in the same segment, okay, or angles subtended by the same chord at the circumference of the circle. All right, so, or you can just write it in short, that is angles in the same segment, So what is it about these angles in the same segment? Angles in the same segment are equal. All right, so meaning to say, if they are equal, that means therefore angle M1 is equal to R2, and R2, remember, we calculated this before, we got 21 degrees. So meaning to say this is also 21 degrees. All right, that is not the only way that we could have calculated this angle. We could have calculated first angle O2. All right, remember here, angle O2 can be calculated from 138 angles on a straight line. You calculate angle O2. What is our angle O2? Angles on a straight line, that is 180 minus this 38. All right, you obtain this angle that you have at this point, 180. This one I did not even prepare. Let me just show you guys. 180 minus 138 is something like 42 degrees. All right, you obtain 42 degrees at O2. Then remember that O2 and M1, this is the idea there. M1, the angle at the circumference, is also from the same chord, but this chord is creating angle at the center. So we know that angle at the center is twice angle at the circumference. So to obtain angle M1, you are going to divide, because M1 is at the circumference. So that was going to be another way that you could have answered. There are so many ways, guys. If there's another way, let us know on the comment section so that someone can also learn from your ideas also. All right, 8.14, angle M2, if it is further given that NO is parallel to NR, and that is 4 marks. If it's an assumption, if we are assuming that these two, they are parallel. It's an assumption. NO is parallel to PR. Where is NO? This is our NO here. NO is parallel to PR. We assume that these two are parallel. The moment that we assume that these two are parallel, it means the properties of parallel lines has to be applied. Now I have to bring you back to your mathematics grade 10, your mathematics grade 11, 9 there, where you had to work with the parallel lines. So I'm not going to dwell much into that. Let us talk about this question. We need to calculate angle M2, provided that these two lines, they are parallel this time. They are parallel. So how am I going to calculate this? All right, 8.14, what is going to be our angle M2? We do not know. All right, but the first thing that we can consider about this angle M2 is that there are actually so many ways that you can answer this. There are actually so many ways that you can answer this. All right, about angle M2, this angle that we are seeing, we can consider angles in a triangle. Remember, we have got a triangle MPR as a right angle triangle already there. So it means if I can have this angle here, which is MPO, this angle here, if I can just have this angle, it can help me a lot considering angles in a triangle concept. So this means that I can calculate the angle MPR. I want you to see what is happening with angle MPR. Angle MPR is inside of triangle MPR, inside this triangle. That is why I'm focusing with this, because already there's an angle here. So if I have a second angle, that means I can obtain this angle at M using angles in a triangle concept. But I do not have this angle MPR. So is there any angle equal to this due to the condition that we are given that these two are parallel? These two are parallel. That alone satisfies us to say the angle O2 is equal to angle MPR. Why? The concept now is of the alternate angles. We are creating a Z as we are moving from one point of the paraline like this. Look, we are creating a Z, alternate angle. So the angle O2 here and the angle, this one, our MPR, they are equal. So it means angle MPR is equal to angle O2. For the fact that these two are equal, it's an advantage because I can calculate O2. Remember, I actually talked about calculating O2 when I said if you want to use that. So I already talked about that. All right, I already talked about that. All right, so the reason that we are putting to say these two are equal, we saw that is all about what? Alternate angles, all right? So we are referring to the alternate angles since NO is parallel to what? Since NO is parallel to PR. Okay, these two are parallel. So by determining that these two are equal, that means I can determine angle O2 because it's simply on a straight line, and I understand that angles on a straight line simply 180 degree, add up to 180, or O2, I can take it from R2 angle at the what? Angle at the center is twice angle at the circumference. I don't know the way that you can, or you can take it from M1 to this angle at the center is twice. So guys, there were so many ways to calculate angle O2, or you can just subtract 180 degrees minus 130 angles on a straight line, on a straight line, and so forth. All right, so you're going to write the reason there. That was going to give us 42 degrees. So if this angle O2 is 42 degrees, it means also this angle is 42 degrees, which is our MPR. So having our angle MPR as 42 degrees, how is this going to help us to calculate angle M2? It is going to help us to calculate angle M2 because we have got a triangle here, and we understand that as long there is a triangle, whether it's a right angle triangle, it's a non-right angle triangle, the angles that are inside, they do not matter to the type of triangle. They always add to 180 degrees. They always add to 180 degrees. So meaning to say, therefore, I can calculate angle M2 by simply subtracting these other angles that are inside of this triangle. Which angles am I talking about? The 42 degrees and also the combination of these two angles that I know it is a right angle if I add these two. So instead of me adding 21 and 69, I'm just going to write this as what? As 90 degrees. But I'm not saying it's wrong for you to write this as plus 21 plus 69 degrees. I'm not saying it's wrong. It is just one and the same thing. Just one and the same thing. All right, so the reason that we are doing this is because we are considering angles that are in a triangle. All right, so these are some of angles. All right, sum of angles in which triangle are we talking about? MPR, triangle MPR in this case, triangle MPR, which is they are supposed to add up to 180 degrees. All right, so that's it. We have got our angle M2 from there, which was going to give us something like 48 degrees. Just like that. Just like that. So be mindful whenever you are working with your theorems. Be mindful how you answer your questions. It is very, very important that you do understand your diagrams. Do understand your diagrams. So we are going to have a continuation of the same question paper. Here in question 8.2, we are just going to work each diagram separately so that you do understand the concept. For more, just make sure that you subscribe to this channel for more classes from Maths Zone African Motives. Till we meet again.